Dear viewers, greetings. Welcome to another productivity talk conducted by the Asian Productivity Organization, a Tokyo-based intergovernmental organization established in 1961 to increase productivity in the Asia-Pacific region through mutual cooperation. I am Jitin Kapoor, a program officer working with the APO and the moderator for today's P-Talk, titled Geothermal Energy Systems, Applications, Opportunities, and Challenges for Sustainable Development. Viewers, the P-Talk series is one of the APO's many endeavors in its mission to contribute to the sustainable socio-economic development of the Asia-Pacific through enhancing productivity. And through this series of P-Talk, we aim to disseminate relevant digital content from leading experts and practitioners at the nexus of policy, work, and technology. Today, we welcome Mr. Yash Sen to talk about geothermal energy systems and their applications, opportunities, and challenges for sustainable development. Mr. Sen is an industry practitioner and a qualified mechanical engineer with years of experience and specialization in geothermal heating and cooling systems design and execution, net zero building design, and the integration of building physics with renewable energy sources. Hello, Mr. Sen. I hope you are doing well.
Pretty well, thank you.
Thank you. Thank you, sir. Before I give the floor to Mr. Sen, let me highlight an initiative by the APO to address the challenges emerging from rapid industrialization, which is negatively impacting the environment due to its linear model of take, make, and waste, and overdependence on limited fossil fuels, which in turn leads to all forms of pollution. With the objective of enhancing productivity and simultaneously reducing negative impacts on the environment, the APO developed the green productivity concept against the backdrop of the Earth Summit in 1992. Since then, through various activities, namely capacity building, research publications, and certification body development, the APO has strived to build a critical mass of GP practitioners and experts across the Asia-Pacific region. The recent publication, titled APO Green Productivity 2.0, The Road Ahead, outlines the future course of action, particularly from the perspective of evolving sustainability issues and addressing the needs of member economies. This P-Talk on geothermal energy systems can be categorized under the APO's green productivity concept. Even though the geothermal has been a part of energy systems for decades now, recent technological breakthroughs have unlocked huge scope in terms of meeting energy needs at a low cost and without negatively impacting the environment. With this, I now give the floor to Mr. Sen on his presentation of geothermal energy systems. Over to you, sir.
Thank you so much, Mr. Jatin, and I would like to thank you, APO, and Mr. Jatin, for giving me this opportunity because this is a very right time to discuss about the geothermal energy because of the climate change and various symptoms we are getting these days because of the rain and the uneven climate issues. So today we are going to discuss about the geothermal energy systems in which we'll talk about the applications, opportunities, and challenges for the sustainable development. So basically, from a decade, I am working in this field and did few of the projects which is having a renewable integration with the building physics, in which we can make a net zero building by integrating the geothermal and solar PV. And definitely, a building physics or the passive approach plays a very critical role in this. So let's start this and okay. So today we are going to more discuss about the geothermal heating and cooling application. Basically, whenever we think about the geothermal, we think about the electricity, the power generation. But definitely, there is a direct use of geothermal heating and systems, heating and cooling systems also. So we are going to discuss that one today. So there is a very famous German sustainable philanthropist, Eugen Jetz. he said sustainability is no longer about doing less harm, it's about doing more good. So definitely, we already did a lot of damage to the earth, and we can see the symptoms. So now it's time to do some more good work, and by implementing renewable sources, definitely we can achieve some good for you can say a good for earth. So definitely we are going to discuss that things in the coming slides. So my today's content is basically all about the climate change, sustainable development goals, sources of energy, all about the geothermal direct applications, in which we are going to discuss about the ground source heat pumps, and then we'll talk about the Asian market, how is the trends going on, what HVAC systems normally people use right now, and what better we can do. Then we'll talk about the geothermal opportunities in the Asian market, a net zero approach. So definitely we can implement geothermal to get the net zero. You can say a net zero buildings can be made by using the integration of geothermal and solar with the building physics. Then we'll discuss about the current policies we have in the Asian market for the geothermal installations, then the current challenges. So these are the things we are going to discuss today. So from here, I will start the my presentation, the basic presentation, in which we will talk about the climate change first. So as you know, the symptoms are coming up. We have uneven rain patterns. The climate is changing. This is all because of our previous tasks we did to the earth, because whenever we are talking about the thermal comfort, we are using the systems which are not good for the environment. So carbon emissions are there, greenhouses gases makes this effect and damage the earth. So here on the screen you can see that as per our agreement, Paris agreement, we are already in 2022.89 degrees Celsius. So we all pledged that we will not increase the temperature of earth 1.5 degrees Celsius, and we will be below that range. But in 2024 we are already now crossing that temperature, because various cities and countries now facing the increase in temperature. So that is again a big issue. So, with the climate change, you can see that there is changing rain patterns. We have already damaged corals, rising sea levels, warmer oceans, changes in the life patterns, plant life cycles. So, all these symptoms we are already facing the challenges right now, and glaciers are melting. Even in the last yesterday, I am reading the newspaper, and the deep sea species are coming up on the sea level. So this is again a challenge we are facing these days because of the climate change. So what are the why this is happening? The possible thing is because of the more severe storms. These are the effects we are now going to discuss, in which we'll see the hotter temperatures, more severe storms, increased droughts, warming, rising ocean levels, loss of species, which is a big concern now. Not enough food because the agriculture practices are now changed, more health issues, risk, poverty, and displacements. So all these things we are regularly seeing in our environment because of the climate change. And what are the causes of climate change? Why this is happening? So as you know, we are generating power with some fossil fuels, manufacturing goods, powering building, producing food, using transportation, cutting down forests, consuming too much. So basically, what we are doing for our needs, we are depleting the natural resources of Earth, and definitely this is giving a huge challenge to us to mitigate the climate change, because in climate change we are getting a very serious issues these days. So we need to focus on the things in which we can make the changes by just doing some you can say, if we integrate with the renewable sources, and if we use the sustainable approach, then definitely we can mitigate the climate change. So, how we can mitigate climate change? Actions to reduce emissions that cause climate change. Basically, we need to reduce the carbon emissions. So how we can do that? We can use the sustainable transportations. As you know, the EVs are everywhere now, because they emit less carbon emissions. Definitely, in some countries we have more power production with the coal. So it's again a challenge for us, but we need to see how we can optimize the transportation so that we can emit less carbon in the environment. Then we'll talk about energy efficiency. Every appliances, every HVAC system, or you can say LED lights, we need to think about the energy efficiency first, and renewable energy. So by integrating the renewable energy in the buildings, we can definitely reduce the carbon emissions. So what is the adaptation we need to find out? So we need to work on the infrastructure. Definitely, we are doing some work in the sustainable approach, but definitely we need to work on infrastructure also. The flood protection, disaster management, and business continuity. So all these things we need to take care for making the for making the environment good. So we need to optimize the system by thinking of urban forest, like there should be greenery and the concrete, but both will be in the optimum situation that we can get the best of it. Then complete communities, water and energy conservations. So definitely there is some issues with the energy and the water conservations, because right now there is issues of water everywhere. In many of the cities in India right now, we are facing a big problem. So we need to work on the energy conservation and water conservation, and this is must. This is a very serious problem right now. So now let's talk about sustainable development goals. As you all know, by UN we have 17 sustainable goals, and if we talk about the thermal comfort or heating and cooling, we need to talk about the five of the sustainable development goals, in which we have the third one is the good health and well-being. Definitely, for the comfort and the well-being, we need the heating and cooling systems. Then we have mitigate and clean energy. So we need to work on the renewable energies. We need to see what best we can do to take from the nature. Then, if we talk about eighth SDA, which is decent work and economic growth, so we need to think about what best we can do for the decent work environment and the economic growth of the country, because the energy and water are the biggest challenges we are facing right now. So it plays a very major role in the economy of the country. Then we have 11th is the sustainable cities and the communities. Definitely, for making, because of the population increase and more construction is going on, we need to think about the sustainable cities, how we can implement and integrate more passive approach in the buildings. That is more important. Then 13th is the climate action. So definitely to we can say, like, if we want to reduce the carbon emissions, we first need to see what best we can do in the by using the sustainable approaches or by using the natural resources. So in climate action, we have this thing. So out of 17 SDAs, 5 SDAs are very important, which are related to thermal comfort, and today we are going to discuss about it. So now let's talk about the sources of energy. So whenever we think about the renewable energy, we think of wind, hydropower, solar, geothermal, and biomass. Solar is very famous renewable energy, and most of the integration, or you can say the penetration in the cities and the states are already doing a lot of work in the solar. But geothermal is still at very low pace, because this is not a common technology in US and Europe. This technology and this power generation from the geothermal is very common. But if we talk about the Asian market, still we need to work a lot of things on it. So this is all about the renewable energy, and already we are using a lot of energy from it. Then we have non-renewable energy, in which we'll talk about the oil, gas, nuclear, and natural gases. So here the issues are we are depleting these non-renewable resources at a large scale, and now we need to switch to the renewable resources. So if we think about the geothermal energy, whatever comes in the mind is first the power generation. So the power generation is basically an indirect application in which we are using the geothermal energy. Uh, we are using the thermal energy and just converting it to the electricity or power. So that is an indirect application of geothermal. And whenever we are using the thermal energy for our thermal comfort, that is the direct application of the geothermal systems. So geothermal heating and cooling systems for sustainable future. So on the slide, you can see that there are loops in the ground which are used for the heat sink and extract of thermal energy, which can be utilized in the building for the thermal comfort. So today we are going to discuss how we can implement the geothermal heating and cooling systems, what are the challenges, and what is the basic technical things we need to take care while installing the geothermal systems. So this is all about the basic, like whatever the sun intensity we are getting on the earth, the 51% of the energy is trapped inside the earth. That can be used for our thermal comfort, because that shallow energy, the shallow heat storage, we can use it for our thermal application. So here you can see that 51% energy is absorbed in the land. Other are 6% is reflected by atmosphere, by clouds 20%, reflected by earth surface is 4%, atmosphere 16%, and clouds absorb 3%. So 51% is a big, huge amount of solar intensity or the heat which is trapped inside the earth, that we can use for our thermal comfort. So geothermal works basically on the stable ground temperature, in which we are utilizing the stable ground temperature for our thermal comfort. So on the screen you can see that we have a graph which is showing a typical ground temperature of Malaysia, in which if we go down to the earth, like above or below 10 meters, you can see we have the constant stable temperature throughout the year. So that temperature we can utilize for our exchange in the soil. Uh, there is one more picture which is showing on the slide, which is showing that the heat is trapped in the earth's surface. And if we go below 10 meters or 20 meters, it again depends on the geology of the area. But most of the countries is having the stable temperature if we go beyond 30 meters, right? That it again depends on what soil type we have in the geology, how much water we have. But definitely this is a common scenario which can be seen in all the geology, where we can get the stable temperature. So now let's talk about the ground source heat pump. Basically, a ground source heat pump is the heart of the geothermal system, which is having a Carnot cycle or vapor compression cycle or refrigeration cycle. So we have this cycle inside the ground source heat pump, in which we have compressor, condenser, expansion valve, and evaporator. So as per our season requirement or as per our indoor requirement, we can utilize the ground source heat pump for heating and cooling purpose. This can make simultaneously ground domestic hot water also as per our needs. So this is all about ground source heat pump. It is having a vapor compression cycle inside. And then we have on the distribution side, we have FCUs, radiant heating, cooling, whatever the indoor system you are going to use. And on one side, we have the ground loop, which is attached to the condenser part. So here you can see that we are using a vertical loop in one of our project, and in the heating mode, we are giving radiant and heating by the floor. Cooling mode, normally we use FCUs and AHUs. There are many other indoor applications also which can be used in both the systems. So on the screen, you can see that we have both the cycles in which a ground loop is working with the exchange of energy. So why this is very beneficial to install a geothermal system? Because geothermal systems work on 400 to 500%, whatever the systems we have right now in the conventional HVAC system. If we talk about VRF systems, splits, water cooled chiller, air cooled chiller. But this is the technology which is having the most optimum and the highest COP energy levels. So you can see that we are getting 3 to 4 units of free energy. This is again an average, but in some of the countries and some of the installations, we are getting even more of it. So basically, if we give 1 unit of energy or electricity to the ground source heat pump, we can get easily 4 to 5 units of thermal heat. So on the screen, you can see that we have sort of two systems, heating and cooling, which can make domestic hot water also with the heat recovery. So this is a benefit of geothermal system. So what are the loops we have for making the geothermal system? Basically, there are two types of loops: closed loop system and open loop system. Closed loop system are very common everywhere because there is some challenges with the open loop system. But again, that's part of design. How best and what best we can do to that geology. So in the closed loop system, basically we have three sort of systems. One is vertical loop, horizontal loop, and then we have the slinky loop, which can be used in the pond and in the horizontal lines also. So this is the animation which is showing the different types of loop, and then we have the soil characteristics. These soil characteristics are very important whenever we are designing a geothermal system. Geothermal system is completely based on what geology you have inside the ground. So you can see that if we have dry sand, the thermal conductivity is not that good. But if we talk about the saturated sand or a moist sand or clay, we are having a very good thermal conductivity. The more the thermal conductivity, the better we can exchange the heat from the ground. So soil is very important factor while designing your ground source heat pump. There are many tests in which we can use thermal response test in which we can do to see what type of soil we have and what best thermal conductivity we will get. So again, this is a practical pictures which is showing the different types of loop. You can see here we have horizontal loop, slinky, vertical, pond loop. So these are all types of closed loop systems in which we need to circulate the water media. You can use the antifreeze also as per the geology, but this is how a system looks like after doing the installation. So now let's talk about the practical way in which we'll see how we'll install the geothermal system. So this is a schematic line diagram in which is showing the geothermal bore wells. Then we have the ground source heat pump. Then we have one buffer tank which is showing heating and cooling applications as per our need. Then we have domestic hot water. So this is basic schematic, and then we have one picture which is showing installation, which is the actual installation of the geothermal system. It's a plant room. Now let's talk about the thermal response test. This thermal response test is basically a very important test we need to do while designing the commercial installations. So by doing the thermal response test, we need to get the soil properties, the thermal conductivity of soil, and diffusivity, volumetric quantity of heat. So all these properties we can easily calculate from doing the thermal response test. Normally this test runs for 36 to 48 hours, and this is again a continuous test in which we need to run hot water inside the ground loop and need to check what temperatures we are getting when the water is coming out. So this test normally we have this sort of machine, and we do a lot of tests when doing the commercial installations. Geothermal probe with weight. Here you can see we have HDPE pipe, or you can say a probe with a weight, which goes inside the bore well, which is using a heat exchange from the ground, and that we can use for our thermal integration in the ground source heat pump. So this is a thermal probe that we are using. Weight is basically needed to overcome the buoyancy of water if we have water inside the bore well. So this is again a sort of design calculation in which we need to calculate how much weight we need to put on the probe. Geothermal grouting is very important here because grouting needs to be done properly if we want to exchange the optimum thermal heat from the ground. So grouting is basically uh, you can say a slurry which is goes inside the bore well, which helps or act as a catalyst in improving the thermal conductivity of media from the soil. So here you can see normally geothermal grout is a mixture of silica sand and bentonite, and then again as per the geology we need to find out the ratio, what ratio we are going to use for the making the grout. So this is again a very important factor while deciding the uh, grout type. Now we have lot of benefits of installing geothermal systems, because when we talk about the conventional systems, most of the systems depends on the ambient temperature. So whenever we think of installing the geothermal system, we are basically exchanging the heat from the ground. So we are using the stable temperature of the ground, which is constant throughout the year. So, as you all know, the climate is changing, and the main, the basic, I can say, the buildings are contributing a lot of carbon emissions, because while using the HVAC system, as you all know, 60 to 70% of the home heat is going in the thermal comfort systems. So whenever we talk about the water cooled chillers, air cooled chiller, VRF system, they have their loopholes, because whenever there is increase in temperature, or we have winters, peak winters, these systems just these systems are not good because of the less efficiency. So we need to work out what best we can do while installing the geothermal system. In geothermal system, basically, but the earth stable ground temperature plays an important role. Whatever the temperature you have outside or in the ambient temperature, that is not going to impact the system. It will give you a constant COP throughout the year. So that's the best part of geothermal system. So geothermal system, it will increase the property value. Definitely, you can sell your property as the infrastructure of geothermal system. If you have the vertical bore wells in your ground or in your premises, you can say that this is again a sort of infrastructure. The basic thing is, because we are getting more energy from the earth and not utilizing grid energy, uh, whenever the price will increase, the electricity price will increase, it is not going to impact the geothermal system, because the same energy, the free energy, we are going to use from the earth. So we are getting a constant temperature, constant thermal comfort from the geothermal system. Energy efficiency is there because it is not dependent on the climate. We are exchanging the heat from the ground. Cost savings, if we talk about the cost savings, total cost of ownership, definitely we have a huge capex while installing the geothermal system. But if we talk about the life cycle of geothermal system, they are very more efficient, and the ROI simply comes inside 4 to 5 years when we do the ROI calculations and the capex and OPEX calculations. Environmental impact, this is again a carbon neutral technology which is not emitting any emissions in the environment. what we are doing is we are utilizing the earth as a battery to just recharge or discharge the earth battery for our thermal comfort. So as per the season we can utilize the thing. Longevity, these systems work for, like, the loops work for 50 plus years and the ground source heat pumps works 25 plus years. So if we talk about the VRF systems, normally they work for 12 to 15 years, and again the chillers life is 15 to 18 years. But if we talk about the geothermal systems, they work 50 plus years. So again we are having a huge potential in the OPEX calculations while taking considering the maintenance and the life of the system. Low maintenance because everything is inside the ground. We are not having we don't need to do any maintenance in the ground part or the condenser part. Everything is inside the ground. So definitely these systems are closed systems. They need there is no need of doing lot of maintenance. We just need to clear the filters, and because of the closed loop there is no scaling in the system. That's the best part of geothermal systems. So again we are using very less in the maintenance, or you can say the money we are going in maintenance is very low. Then consistent comfort, because we are exchanging the thermal heat from the ground. There will be a certain RH there, so we'll get the constant RH inside the room, and the thermal comfort is very much comfortable for all of the temperatures, either in peak summers or peak winters. When we can say about the versatility, this system can work for heating and cooling both simultaneously. It is making the hot water also. So geothermal systems are best when we talk about the comfort system right now. This is the most efficient heating and cooling systems in the world right now. So let's talk about the current geothermal energy trend in the Asian market. So on the left hand side, you can see that it is showing the graph, which is showing that what market we have right now and what is the forecast. So you can see that a CGAR of 9.5% is going from 2024 to 2034. So this market is increasing day by day. In the Asian market also, like the countries China, Japan, India, South Korea, these countries are doing a lot of installations, and this market is going to be a good. I can say if we talk about the renewable sector, this segment is going to be at a huge level in the coming years. So now let's talk about the geothermal opportunities, a net zero approach. So already, as I told you, in the Asian market also, a lot of countries are doing geothermal installations, and China is the biggest one in the Asian market because they are putting a lot of district heating and cooling systems to cater the societies of the sustainable cities. China is doing one of the company is Arctic Green. They are doing a very good work and doing the big installations there. If we talk about Japan, Japan is again very good, making very good heat pumps, and in the future also we are getting more installations of geothermal for heating and cooling applications. Because whenever we talk about the Asian countries, we are doing good in the geothermal power generation. If we talk about Philippines, New Zealand, they have very good potential for the power generation, where we can use the deep earth for making the electricity. But now the traction is getting for the geothermal heat pumps also, and lot of systems are and lot of buildings are now installing the ground source heat pumps. So in the Tokyo, we have these sort of installations. In India, this is one of the project we are doing in the northern part of country, where we are doing a lay assembly which is having 140 kilowatt geothermal system with the 22 borewells of 100 meters. So this is again a closed loop vertical system in which we are doing radiant cooling or radiant heating and cooling with the geothermal heating and cooling system. In few days we need the cooling also in Leh in summers, but most of the part we need the heating there. So these systems we are doing right now, we have our own TRT machine, we did the calculations, we checked the soil, and we are getting a very good conductivity because the soil is mostly saturated soil below 40 meters, and the water level is also good, so we are getting a good thermal conductivity and diffusivity there in the ground. These are some of the projects which are already installed in India in the Indira Paryavaran Bhavan, which is the Ministry of Environment and Forest. Now, biggest system of geothermal in India, which is 2.5 megawatt geothermal system for Leh Airport. It is going to install now, and work is going on. So the traction of geothermal is increasing in Indonesia, Japan, India. These are the countries now thinking about making the sustainable, because every country is having their sustainable goals. And by installing the geothermal system with integration of solar, definitely we are going to get that uh, the best of it. Here you can see that in the Thailand also there are some installations of geothermal which are going and already installed. So again, the traction is a lot of in the Southeast Asia also. So now let's talk about the attractive opportunities in the geothermal market. You can see this is saying about the Asia Pacific, and the projected CAGR is 5.9%, which is a huge, if we can say, in the renewable sector. So this market is increasing, we are getting a lot of opportunities. Every day I am getting call for geothermal installations, because this is a need of an hour. So we need to think about the geothermal installations and renewable energy sources. If we talk about the policy landscape in Asian market, all the countries is having their own policies for geothermal power generations, but now they are making the policies for the ground source heat pumps also. So in if we talk about India, we MNRE is already in planning to dispatch or release the policy which is having a subsidy on the ground source heat pumps. If we talk about the China initiatives, they are already doing good with the installations, and they are getting some rebates and the tax benefits while installing the geothermal systems. ROC Republic of China, Taiwan is also doing some installations, and they also have some policies and the goals for sustainable futures. Indonesia is doing some installations. So these are the countries which are doing very good, and the traction is going on for the geothermal installations. Already, one of my friend in Australia, Yale, they are doing a great job. They have big company, and most of the commercial buildings now going for the geothermal installation, which is very good for Asian Pacific market. So what are the current challenges we are facing whenever we are pitching the geothermal applications in Asia? The problem is the technological limitations. The first thing is the lack of technical expertise. We have very few people who knows this technology. So definitely this technology is very established in the US and Europe. So we need to learn a lot of things from there. And evolving technologies, the issues right now we have is we have the conventional systems, but we are not thinking about the new systems which are already established. So we need to think of new technologies, the renewable energies, for thermal comfort, so that we can easily get our sustainable goals and overcome the challenges we are facing for the climate change. Then there is regulatory issues, because the policies are not good. Some countries are still working on the policies, but they have not released yet. So we need to see what policies are coming up, what incentives will get, what tax benefit will get from installing this system. Because if we talk about the solar, Solar is already established everywhere, and we are getting some subsidies and rebates from the government also. But right now, for the geothermal, this is again a new thing. High initial cost, definitely, if we talk about Asian countries, because we don't have that much tools, or the ground source heat pumps manufacturers are very less. uh, the upfront cost is very high for installing the geothermal system. But if we talk about the overall investment, we are getting a ROI of 4 to 5 years only. So definitely, one need to implement this system, taking care of the environment also. Then we'll talk about public awareness. Very few people know this technology because awareness is not that much penetrated. So in the Asian market, very few people or the organizations know about the geothermal systems. So that we need to work out. More awareness is needed for each of the country for the economic growth. So, in the conclusion, I just want to say that if we implement or install geothermal systems, definitely we reduce the energy cost, we lower the emissions, carbon emissions. It is good for our environment. Economic growth, definitely, this will stabilize our grid also, and it will help the country in economic growth. Policy collaboration, government is now taking interest in making the policies for geothermal direct applications, ground source heat pumps. So definitely this is going to be a big thing in the future, where this system can be easily accommodate in the mainstream, and we can easily employ for our thermal comfort. So this is whole from my side for the geothermal heating and cooling application, and definitely I think by spreading the awareness by these programs, like APO is doing a great job, we can easily grab the market and make this in the mainstream. Now I hand over to Mr. Jatin for the next step in the presentations.
Thank you indeed, Mr. Sen, for your wonderful presentations and the insights into various technical aspects of geothermal energy systems. I'm sure that the viewers have gained a deeper understanding of this emerging technology that is clean and available in abundance in many areas, as you mentioned, across the Asia Pacific. Now let's move on to the question and answers session. You mentioned about the in your heat recovery slide regarding the comparison between the geothermal systems and the conventional HVAC systems. So my first question is related to that only. That means, how does the performance of these geothermal systems compare with the conventional HVAC systems beyond what you have already elaborated, especially within the context of the Asia Pacific climates?
Okay. So basically, whenever we talk about the conventional systems, we think about VRF systems, air cooled chiller, water cooled chillers. But these all systems are dependent on the ambient, because we are just rejecting the heat in the environment. So whatever the temperature we have in the environment as per the seasons, because in the peak summers, these systems doesn't work on that COP which company claims, because that degrade is there in the machines. But the geothermal systems are already taking the stable heat from the ground, which is a stable temperature there. So throughout the year, you will get the constant COP. So if we talk about the conventional system, the COP is between 1 to 3. But if we talk about the efficiency of geothermal system, it is normally 4 to 5. Again, it depends. It sometimes extend to 7 to 8 also, as per the design, or I can say what sort of loop you are going to use. So definitely, conventional systems are not that good for our environment. We need to switch to renewables mode, in which we can easily integrate the geothermal system with the solar.
Thank you. Thank you. So the COP is the main differentiator in this case.
Yeah,
So
efficiency.
moving to the next question, which are the countries or the regions, especially in the Asia Pacific, which are currently leading the in geothermal heating and cooling adoption? And what is the reason behind that?
Okay, very good question. So, as I already told you, many of the Asian countries now getting the traction for the geothermal market, because nowadays this technology, because this is already established in US and Europe. So many of the installations are already going on. And if we talk about China, they have huge geothermal system for district heating and cooling. Japan also, they are making good heat pumps, ground source heat pumps, which are based on IoT, and they are now working on more efficiency by using the inverter compressors, and a lot of new technologies of or the integrations are coming up in the geothermal systems. Then, if we talk, South Korea is already having some installations, and they are getting a good benefit of the technology. So, commercial buildings in South Korea, they are using the geothermal systems. Then, New Zealand, again, they have good potential for this technology. Australia is already working, and there are many big companies who are already installing the system. So these are the countries where the system is not new. But if we talk about Bangladesh, India, Philippines, here we need to now the people are starting talking about the geothermal systems. So they are getting more traction, and I think in the coming future we'll get more projects and will work towards the sustainable goals.
Okay, thank you. Thank you for your response, sir. So my next question would be focused upon the soil conditions. Of course, you have elaborated about the soil thermal conductivity in specific in your presentations, but to what extent these soil conditions and geology affect the feasibility of the geothermal installations in the again in the Asian perspective, especially from the financial point of view? That means if it is
Okay.
more than this, does it impact the cost of the overall geothermal systems?
Okay, so soil properties are very important while doing the any installation for geothermal, either open loop or closed loop. So whenever we are talking about the closed loop system, they basically work on the properties of soil. So as I told you in one of the slide also, every soil type is having some sort of thermal conductivity. So we need to find out by doing the thermal response test, in which we'll get the thermal properties of the soil, what sort of soil strata we have, and if it is a dry sand, we don't have a good thermal conductivity of that particular soil. Then we need to work out the feasibility of that system there. So if we have water level, the water levels are good, definitely it is easy to dissipate the heat or extract the heat. So water levels also plays a very important role while designing the geothermal system. See, the soil which is moist or the saturated sand, or you can say a clay, then easily we can install the systems, because there will get the good thermal conductivity. So if we check the complete soil strata or the average out each of the portions of the strata, will get a very good thermal conductivity while doing the TRT test. So whenever you are going for any commercial applications or big installation, we need to first do the TRT test, which will which will tell us what sort of soil we have and what groundwater level we have there. So this is again a very important factor while designing the geothermal systems.
Hmm. Okay, thank you. So maybe given these design constraints and the considerations, what are the innovations in the geothermal technology which are making these geothermal systems more cost effective and accessible?
Right. So this is again a very nice question, because lot of things are coming up in the geothermal market, because lot of innovations is going on. As I told you, this technology is already established in US and Europe market. So now the manufacturers or OEMs are coming with more innovative solutions. The new refrigerants are coming up, like many of the manufacturers are making ground source heat pump with propane R290. So that is again a very good refrigerant for the environment. If we talk about the green refrigerants, many of the geothermal systems or the ground source heat pump, I can say, they are coming with the IoT based system. So easily we can control or integrate the system with the different conventional system. If we talk about the air to water heat pumps or the aerothermal system, we can easily hybridize the system by doing both this and integrating the solar also. So there are some heat pumps which are coming with the controls in which we can integrate the solar thermal, the collectors also, and the PV also. So lot of work is going on. One of the person I know, Mr. Lawrence, he is making a software which we easily check the thermal properties over the period of the installation, over the period of operations inside the ground, and from there we can see what maintenance need to be rectified in the future. So these are the softwares coming up in the market, and um, few of the companies are making very small heat pumps which are just a shoebox, very small one, which are for the residential 3 to 6 kilowatt heat pumps. So these are the heat pumps. I think in the future we are getting a lot of opportunities with this technology because lot of work is going on in the Western world.
Okay, so that means there's a lot of huge scope, as you have already explained. But
Yeah,
once we talk about the water conservation effort, so how these geothermal system, because they use a lot of water, right, in terms of
right, right.
the installation. So how these geothermal systems impact the water conservation efforts in the regions which are of very high water stress?
Okay, so whenever we talk about the conventional systems, either it is air to water or the water cooled chillers, every day we are losing a lot of water in the evaporation. If we talk about the evaporative cooling also, we need to give lot of water. So now the next battle will be for the water, and we need to conserve the water. So geothermal system best benefit is it is a closed loop system in which we just need to fill the water one time while doing the commissioning, and that then water will work throughout the life. In the maintenance, if needed, we need to change the water because sometimes we need to add glycol also as an antifreeze in some of the systems. So definitely, but the water need is almost zero in geothermal systems, and wherever we have deficiency of water and scarcity of water, these systems can play a major role. So I think geothermal system can help us in reduce water in HVAC system because they are not using any sort of water.
Okay, thank you, Mr. Sen, again for providing your further insights into the geothermal energies to our viewers. So, while looking forward to your continued support, sir, and the guidance in our activities, particularly on the green productivity concept and the framework, and the we now come to the end of this free talk. With this, I encourage the viewers to please provide their feedback, input, or the questions in the comment section below. And we at the APO Secretariat will promptly contact Mr. Sen for his response. So, with Mr. Sen, may I please invite you for any closing remarks, sir?
Definitely. So I just request everyone, or it's because all the countries is having their sustainable goals, and definitely we need to reduce the carbon emissions. So this technology will play a very important role. If we install the geothermal systems, definitely we can conserve energy and water. So it's a appeal or appeal to HVAC contractors, consultants, or whatever the stakeholders having in HVAC industry. Let's bring this technology in the mainstream by installing more and more installations. And definitely, I think by this technology, we can easily achieve our goals for the net zero nations.
Okay, thank you, Mr. Sen. With this, again, a request to our viewers to please subscribe to the APO's YouTube channel to stay updated on the upcoming P Talks on interesting topics. Thank you for your valuable time today, Mr. Sen and the viewers, and see you all soon in the next P Talk on an interesting topic. Thank you and goodbye.
Thank you.